Crystal defects or imperfection in crystals or lattice imperfections. A defect or imperfection is present in a crystal when the arrangement of constituting particle is not perfectly regular. These defects are due to presence of impurities or defects in the formation of lattice. Types of defects. There are two types of defects. If we classify them broadly, with point defects and line defects. Line defects are also called dislocations. Point defect. Imperfection in a crystal are caused by departure from the periodic arrangement in the vicinity of an atom or group of atoms. The imperfections are called point defects. These arise from an error at a single point. Types of point defect. Point defects are classified into three types: Stitumetric defects, impurity defects, and non-Stitumetric defects. Stitumetric defects. These are point defects that do not disturb the stoichiometry composition of the solid. They are also called intrinsic or thermodynamic defects. They are of two types: vacancy defects and interstitial defects. Vacancy defects. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. Large number of vacancy defects lead to lowering in density of crystal lattice. Shortcut defects belong to this category. These are called thermodynamic defects because they can develop on heating. Interstitial defects. When one of the constraint particles is missing from its position but occupies a position meant for another particle is called interstitial defects, as shown in the figure. Figure A shows interstitial defects in non-ionic solids, whereas figure B shows interstitial defect in ionic solids in solid. In ionic solid, in spite of interstitial defect, electroneutrality is maintained. Frontal defect. This is due to the shifting of an ion from its normal position to an interstitial in the crystal lattice, thus causing a vacancy in the original position. The overall density is not affected by this change. These defects are found in silver halides, example AgCl, AgBr, AgI and ZnS. It is due to the small size of Ag plus and Zn2 plus ions. The size of cation and anion differ appreciably. The anion is much larger than the cation. Shortcut defect. This is due to missing of cations and anions from their positions. A vacancy of one of the ions is accompanied by the vacancy of the oppositely charged ions so that electrical neutrality is still maintained. Thus, overall density of the substance decreases. Shortcut defect is found in AgBr, KCl, NaCl, CaCl. AgBr shows both Frankel and shortcut defects. In NaCl, there are approximately 10 to the power 6 Schottky pairs per centimeter cube at room temperature. In 1 centimeter cube, there are about 10 to the power 22 ions. Thus, there is one defect per 10 to the power 16 ions. These defects are possible in those ionic solids in which the cation and anion do not differ in size appreciably. Impurity defect. SrCl2 and CaCl2 is added to the molten NaCl and is crystallized. Some of the Na plus ions are replaced by Sr2 plus and Ca2 plus ions. Each Sr2 plus and Ca2 plus ions replaces two Na plus ions. It occupies the site of one of the ions and other site remains vacant. The number of cationic vacancies are equal to the number of bivalent cations added. Similar example of impurity defect is addition of CdCl2 to AgCl. Non-stoichiometric defects. Those defects which lead to change in the composition of solids are called non-stoichiometric defects. They contain constituting particles in non-stoichiometric ratios. Example: Fe 0.93, O 1.0, nickel, Ni 0.94, O 1.00 are example of non-stoichiometric compounds. These defects are of two types: metal excess defects. It is due to anionic vacancies. B. Presence of extra cation in interstitial sites. Metal excess defects due to anionic vacancies. These types of defects are produced when metal halide is heated in metal vapors. Example: when sodium chloride is heated in sodium vapors, Na plus ions becomes in excess Cl negative ions, leave their normal site and come to the surface. The vacancy created by an ion is occupied by the electron forming F center, which absorbs light from visible region and radiates yellow color. That is, NaCl becomes yellow in color when heated with sodium vapor. Similarly, KCl becomes violet lilac when heated with potassium vapors. LiCl becomes pink when heated with lithium vapors. F centers When electrons occupy the vacant positions of an ion due to the presence of excess of metal ions are called absenters. They impart characteristics color to the compound and increase electrical conductivity. Metal excess defect due to the presence of extra ions at interstitial sites. It has been observed when zinc oxide is heated, it becomes yellow in color. ZnO heat Zn2 plus half O2 plus 2 electron. There will be excess of Zn2 plus ions in the crystal which will occupy voids or interstitial, and electrons lost by oxide and occupy neighboring interstitial sites. These electrons absorb light from visible region and radiate yellow color. Metal deficiency defect. This type of defect occurs in those crystals in which their cations show variable oxidation state. In these solids, example in FeO3, some Fe2 plus ions are missing, therefore there is a loss of positive charge. Electroneutrality is maintained by oxidation of Fe2 plus to Fe3 plus, which leads to change in stoichiometry. That is why these defects are called non-stoichiometric defects. Fe 0.93 is oxygen 1.0 and Ni 0.98 oxygen 1.0 are example of non-stoichiometric compounds. Types of solids on the basis of electrical conductivity. Solids exhibit an amazing range of electrical conductivities extending over 27 order of magnitude. One way of classifying solid material is according to the ease with which they conduct electricity. Solids are classified into three types: conductors, semiconductors, and insulators. Conductors. Metals are good conductors and have conductivities in order 10 to the power 7 ohm per meter. Insulator. Those solids which have very low conductivities ranging from 10 to the power minus 20 to 10 to the power minus 10 ohm per meter are electrical insulators. Example: MnO, COO, COO, NiO, COO, Fe2O3, TiO2. Semiconductors. Those solids which have intermediate conductivities generally from 10 to the power minus 6 to 10 to the power 4 ohm per meter are termed as semiconductors. Thank you.